In the following task, we are going to make the robot follow straight lines. This is very useful because in pick and place applications, when approaching an object, it is convenient to use these rectilinear trajectories in order to not shake the object and have really precise movements. This is the code for the linear movement. It is the same as the inverse kinematics code, but now we have two new functions. The first function is the forward kinematics. With this, we give the function the current position of the joints in angular position, and with the parameters of the robot, it returns the position of the tool. In order to do this, the mathematical functions are implemented, and these are the functions that are shown in the slides of the course. With this serial print, we can see in the series monitor of Arduino the position of the tool. This is really useful when we want to debug the code. We have this condition here because, as you remember, we had a problem with joint 3 and its sense of rotation in the simulation is different from the one in the physical robot. So because of that, we have to indicate that when we are working in the simulation, this angular position will be the contrary. Now we go to the second new function, which is moveL, and with this we give the function the current position of the joints, the point where we want to move, the time for implementing the trajectory, the parameters of the robot, and here it should store the value of the joints when it reaches the target position. So first of all, we calculate what is the current position of the tool using the function forward kinematics. So now here we have the point of the tool, the current point. Now we calculate the parameters for the rectilinear trajectory. And we should evaluate this trajectory during time. The last time that this cycle is repeated, it should store in the vector qt the value of the joints, which is got with the function inverse kinematics. This is really useful when we go to the setup code here, because we are saying, okay, go to this point and store here the values of the joints at the final point. So in the next instruction, we can directly use these values without having to repeat the function inverse kinematics, thus making the code more efficient. If we look at the points where we are going, we will see that only one parameter changes each time. This first point is the position of the tool when our joints are 90. Then, when we change this, what we are going is going backwards. Then it should go to the right. Then it should go to the left. Then the tool should move upwards. Then we will go back to the initial position, as you can see in the setup code. From point 4 it goes back to the initial position and then to point 5. So from the initial position now it goes to point 5, in which what we are doing is moving backwards, because this position is lower than the initial height. And finally back to the initial point. Now we will see this in the simulation. We are now in the simulation, so let's start. First it must go backwards, and as you can see the movement is rectilinear. Now it should go to the left, now to the right, and as you can see all movements are linear. Now it will go upwards. Now it goes back to the initial position, making a diagonal movement, and now it will go to a low position following a rectilinear trajectory. So all the trajectories are rectilinear, and thus moveL works as we desired. Now we will go to the physical robot to see how it works. Okay, so I have written down the points in this notebook, and I have written down the sequence of movement. So this is the sequence. And as you can see, the first thing that is going to happen is that we will go to point 1. That means that the robot will move backwards. Then point 2, it will move to the right. Then point 3, it will move to the left. Then point 4, it will move upwards. Then it will go back to the initial position. And this movement will be a diagonal line. Then from the initial position to point 5, which is downwards, and finally to the initial position again, which should be upwards. So here we will now see the movements, and I'm going to be using this roller to double check that the movements are linear. So let's start. And the first movement is backwards. Now to the right. Now to the left. Now upwards. Now to the initial position. And now downwards. And now upwards to the initial position. In this video, we have shown the code to do linear movements with the robot, and we have demonstrated it in the simulation and in the physical robot. The next task will be to implement a pick and place application, so the linear movements will be really useful in it.